In this video, we are going to dive into some more powerful features of SQL. We will be covering advanced SQL commands. Let's get started. All right, let's talk about advanced SQL queries. So far, you've learned the basics like select, from, and where. Now we'll build on that foundation to write more complex and powerful queries. Today, we will focus on three main areas. First, we'll explore set operators, which allow us to combine the results of different queries. This includes commands like union, intersect, and minus. Second, we will look at the subquery, which is a query written inside another query. And finally, we'll master joining multiple tables. We will cover inner join, left join, full outer join, and the very interesting self join. Let's begin with our first topic. First up, set operators. Set operators in SQL are used to combine the results of two or more select statements. Union and union all will merge results into a single set. Intersect will show you only the rows that are common to all queries. And minus will take one result set and remove the rows that appear in a second result set. Let's look at each one with some diagrams. Let's start with union. Look at the diagram. Imagine you have two lists, A and B. Union combines them and automatically removes any duplicate rows. So if 2 is in both lists, it will only appear once in the final result. Now union all is a bit different. It also combines the lists, but it keeps all the rows, including any duplicates. You can see here that 2 appears twice in the final result. You use union all when you need to see every single record, and it's usually faster because the database doesn't have to check for duplicates. The syntax is quite simple. You write your first select statement, then the union or union all keyword, and then your second select statement. A key rule is that the select statements must have the same number of columns, and the data types of those columns should be compatible. To see how this works in practice, let's use two tables, agent and customer. The agent table has information about our sales agents. The customer table has information about our customers. Notice that both tables have the working area column. Now, let's say we want a single list of all working areas where we have either an agent or a customer. We can do this with union. First, we select the name and working area from the agents table. Then, we use the union keyword. And we select the name and working area from the customer table. The result is a combined list. As you can see, we have people from Bangalore, London, and New York, all in one neat list, sorted by the working area.
Intersect compares two result sets and gives you only the rows that are identical in both. It's like finding the overlap in a Venn diagram. In this example, only the values 2 and 3 are present in both set A and set B, so that's what intersect returns. Let's apply this. Suppose we want to find which of our agents are actively handling customers. We can do this by finding the agent codes that appear in both the agents table and the customer table. The query is simple. Select agent code from agents, intersect, select agent code from customer. The result shows us agent codes A003, A008, and A011. These are the agents who have assigned customers. Our third set operator is minus. Minus takes the first result set and subtracts any rows that are also found in the second result set. So A minus B gives you only the rows that are in A, but not in B. In our diagram, the result is just 1. Let's use minus to find if we have any agents who do not have any customers assigned to them. The query is select agent code from agents minus select agent code from customer. This takes all agents and removes the ones that appear in the customer table. The result is agent A007. This means Ramasundar is an agent in our system, but he currently isn't assigned to any of the customers in our customer table. Now, a quick question for you to think about. What happens if we switch the order? What would select agent code from customer minus select agent code from agents give us? This query would show us any agent codes that are in the customer table but are not in our official agents table. This can be very useful for finding data errors. For example, maybe an agent left the company, but their code is still assigned to a customer. Okay, let's move on to our next topic, the subquery. A subquery, also called an inner query, is a select statement that is nested inside another SQL statement. Let's look at this example. The goal is to find all employees who work in the location with location ID 1700. The database runs the inner query first. This query gets a list of all department IDs that are at location ID 1700. As you can see, it returns a list: 1, 3, 9, 10, 11. Then the outer query runs. It selects employees whose department ID is in the list that our subquery created. This gives us the final list of employees. We can also use not in to get the opposite result. Here, we want to find all employees who do not work at location 1700. The subquery is exactly the same. It still gets the list of departments at that location. But the outer query now uses where department ID not in. This finds all employees who belong to any department except the ones in that list. It's a powerful way to exclude data. Now for a very important topic in SQL, joining multiple tables. Real-world data is almost always spread across many tables, and joins are how we bring it all together. We'll cover several types of joins. An inner join is the most common. It returns only matching rows from both tables. Left and right outer joins return all rows from one table and only the matching rows from the other. A full outer join returns all rows from both tables, and a self-join is a special case where we join a table to itself.
Let's start with inner join. The inner join finds the intersection of two tables. It combines rows from two tables based on a related column between them. Look at tables A and B. They're joined on the ID column. The inner join only returns rows where the ID exists in both tables, so we only get the results for IDs 3 and 4. Let's see a practical example. On the left, we have a query that gets department names for departments 1, 2, and 3. On the right, we have a query that gets employees from these same departments. The problem is the results are separate. We want to see the employee's name and their department's name in the same row. This is where inner join comes in. We select columns from both tables. We join employees and departments using the inner join clause. The most important part is the on clause. This tells SQL how the tables are related. Here, we match them where employees.departmentID is equal to departments.departmentID. And look at the result. Now we have a single unified table showing each employee next to their full department name. This is much more useful. Next, let's look at the left join. A left join returns all the records from the left table and only the matching records from the right table. If there is no match for a row from the left table, the result will still include that row, but the columns from the right table will be null or empty. In our diagram, you can see that all rows from table A are in the result. Let's find all locations for the countries US, UK, and China. Our countries table has these 3 countries. Our locations table has several addresses in the US and UK, but notice there are no locations for China, CN. Now we perform a left join. We start with the countries table as our left table. Look at the result. We get all the locations for the UK and the US, but we also get a row for China. Since there was no matching country ID in the locations table, the columns for street address and city are null. This is very useful when you want to find something that doesn't have a matching entry in another table, like a country with no office locations. Now, let's discuss the full outer join. The full outer join is the combination of a left join and a right join. It returns all rows from both tables. If a row in one table doesn't have a match in the other, it will still be included and the missing columns will be filled with null. As you can see, the result contains all the unique IDs from both tables A and B.
Let's use an example with fruits and baskets. We have a baskets table and a fruits table. Notice that the strawberry has no basket ID and basket C has no fruits in it. When we do a full outer join, look at the result. We see the fruits that are in baskets, we see the strawberry, but its basket name is null, and we see basket C, but its fruit name is null. This join shows us everything from both sides. Our final join is a special one, the self join. A self join is used to join a table to itself. This sounds strange, but it's very useful when you want to compare rows within the same table. A classic example is an employees table where one of the columns is manager ID. The manager is also an employee in the same table. To find the name of each employee's manager, we can join the employees table to itself. The key is to use aliases. We treat the employees table as two different tables, E for the employee and M for the manager. The on clause then matches the employee's manager ID, E.manager ID, with the manager's own employee ID, M.employee ID. The result is a clean list showing each employee and their manager's name next to them.